and of course, Kelaine Ravdin. We will be having a question and answer period at the end of Kelaine's presentation. Please submit your questions in the questions box, which is in the upper right corner of your screen. And keep your questions pertinent to the greenhouse gas calculations topic. Ashley will organize the questions and read them aloud to Kelaine for her answers. And we are recording this presentation as well. Both California ReLeaf and CUF will be posting this presentation on our websites, and we will email a PDF to all attendees. And remember that there is another CAL FIRE Grants webinar this Thursday, October 23rd, to learn more if you have specific questions regarding grant procedures and guidelines. With that, please welcome the superlative Kelaine Ravdin. Kelaine has been working in the urban ecology and urban forestry fields for 15 years, including a few years at the Center for Urban Forest Research, working on the data that underline most of the tree carbon calculation tools and urban forestry greenhouse gas protocols. She now works as a consultant in urban forestry. Take it away, Kelaine. Kelaine, are you?
Kelaine, it looks like you have self-muted.
Hang on, folks. Can't possibly have a webinar without a glitch. She was with us a minute ago.
Yeah. Kelaine, you have...
Okay, I got it now. Got it. I figured it out. Sorry. This is a great start, everybody. But as Nancy said, you can't really have a webinar without a technical glitch. Hopefully that is the last of them. But apparently if you push the unmute button, it doesn't actually unmute you. It just makes the weird things happen. Anyway, I'm here. And we're going to dive right in because we have so many things to talk about. First, I would like to say thank you to the California Urban Forest Council, to California ReLeaf, and to CAL FIRE for helping make all of this happen, especially the logistics of the webinar, which obviously are more than I could have handled by myself. So thank you very much for that and for getting the word out. And thanks to all of you for being here. The impulse for this came about when I saw the grant guidelines and realized that CAL FIRE is asking us to estimate the greenhouse gas benefits of trees. And as Jimmy Scheid mentioned in the workshop that I attended, the tools, the policy has kind of outpaced the tools. And they're not necessarily as easy to use as we would like them to be. So I thought that a lot of people could probably use some help figuring out how to do this. So we're putting together this webinar with the idea that at least it will help introduce you, it'll introduce you in detail to one particular tool, and then I'm going to mention a couple of others and tell you a little bit more about them, things you can look into on your own for yourself. So to make sure that we're all on the same page, I want to start by talking quickly about the two greenhouse gas benefits that are mentioned in the grant application. And let me also say, let's just start with a quick vocabulary point here. There are all kinds of greenhouse gases. There's carbon dioxide, there's methane, a bunch of other ones. But as far as trees go, the only one we really care about is carbon dioxide. So I'm going to use those words interchangeably. I'll also probably use the word carbon interchangeably with carbon dioxide. And the reason for that is this very first benefit that we're talking about here in this slide. So one of the most important things trees do in terms of greenhouse gas benefits is sequester carbon. So they pull carbon dioxide out of the atmosphere, split it up into carbon, breathe out the O2 as we know, and then in a much more complicated process than I'm describing it as, they turn that carbon into tree stuff. So the trunk, the roots, the branches, the leaves, the flowers, all of that, and they hang on to that carbon as long as those parts of the tree are alive. So when we're talking about carbon sequestration and carbon storage, those two are kind of synonymous, but we've actually come down, we've kind of made it's a sort of an in-house rule, I guess, that when we talk about sequestration, we're talking about what happens on an annual basis. So that's the amount that from one year to the next, the tree adds to itself as its trunk gets bigger, as it adds new branches. When we talk about carbon storage, we're talking about the total amount of carbon in a tree up to date. So that's not clear right now. It'll become more clear as we go on. But what CAL FIRE is asking us to do for this grant is to tell them what the carbon storage will be of this tree at the end of the project period. So after 40 years, how much carbon dioxide has that tree pulled out of the atmosphere and is holding inside of itself? The second benefit that we're asked to estimate is a little bit more complicated to explain. These are avoided emissions. So the way trees provide this benefit, if we plant a tree strategically to shade a building, it makes the building cooler. Then we have to use less energy to create air conditioning to keep the building warm, right? We know that if you have a tree outside your window, the inside of the room, it's going to be much cooler than it would otherwise be. It means you have to use less energy to cool your house, which means that down there at the power plant, there's the power plant, we're actually producing fewer greenhouse gases to make energy. Now, the good thing here is that in California, and particularly in places where it's very hot and dry, like the Central Valley, say, this benefit can be as big or even bigger than the value that we get from the carbon that's stored in the tree. And lots of other co-benefits flow from this, too, as we reduce our energy use. So when possible in our projects, if we can plan to plant the trees strategically to reduce our energy use, we're going to get a lot more bang for our buck, both in terms of carbon, but also in terms of air pollution and energy use itself. I mean, we have to pay for the energy that we use. So what does it mean to plant the tree strategically? Well, generally speaking, the easiest rule to think of is we'd want to plant the trees on the west. West is the best, east is the second best, where the sun shines most brightly on the building. If we can plant the trees in those locations, and within 60 feet of the building, we're going to get this benefit that we're talking about. So those are the two. And we're going to talk about next, how can we figure out what those benefits are? How can we put a number to them? Because that's what we're being asked to do. Put just a number, two numbers. One number for the total storage for the carbon for the 40 years for all the trees, and one number for the 40 years, the energy benefits for all the trees. So I think we're going to have to show our work. So luckily, this will enable us to do that as well. Remember, note down here, let me just say one thing about these little starred passages. Generally, most of you who've ever heard me give a talk before know that I hate PowerPoint slides that have words on them because you can always read faster to yourself than I can read the slide out loud. But my goal today was to make this both a presentation, but for the PDF in the end to stand as a manual for your use as well. So don't take notes like a crazy person. Most of the information should actually be on the slides and help you to know the critical pieces of each of the things that I'm talking about. So here, remember I said in the last slide, carbon stored total in the whole tree at the end of the 40-year project period. And we have tools that can give us that number. For the avoided emissions, these things are going to change as the tree grows and shrinks. I mean, it grows and shrinks, as the tree grows over time. So we have to calculate these year by year by year by year, and then we have to add them up for the whole 40 years. And I'm going to talk about how we're going to do that. So we have several tools out there in the world that exist to help us do this. They all have their pros and cons. They all do things, some things, and not other things. So I'm going to run through them, and then it's going to be for you to play with all of them as you'd like and see which one suits your purposes the best or which one you feel the most comfortable with. The tree, let me say too, underlying all of these is the same information, all the same data, the same species. There are slightly updated growth curves in the EcoSmart Landscapes tool and the Tree Asset Manager tool, but as I've played around with EcoSmart Landscapes, I haven't found very different results. So I wouldn't say that the difference in the growth curves is so significant that it outweighs some of the other issues. All right, so the tree carbon calculator is the one we're going to talk about today. On the downsides, it only calculates information for one tree at a time. Now, some of you out there are probably saying, oh my God, I'm planting 2,000 trees. I can't do the same thing 2,000 times. But of course, inside that 2,000 trees, you're probably only going to plant 5, 10, maybe 20 species. So what we'll do is figure out the benefits for each one of those and then just multiply it by the number of trees of each species that we have. It's still going to be frustrating, I'm not going to lie, but it's not that you need to do it 1,000 or 2,000 times, just as many times as you have species. And it's a little more complicated than that, and I'll explain that more. You can download that tool at CAL FIRE's website, and as I mentioned, in the PDF, these hyperlinks are live, so you should just be able to click on them, and it should take you right to the places that you want to go. EcoSmart Landscapes is a web-based tool. It also calculates benefits one tree at a time. All of these tools are buggy. Let's call them quirky. They all have their quirks. For me, the tree carbon calculator's quirks are predictable and consistent. I had less success in finding consistency in EcoSmart Landscapes, but I think it's definitely worth having a look at and seeing what your experience is. The Tree Asset Manager is sort of the granddaddy version of EcoSmart Landscapes. It is not free. It's the one on the list that is not free, but it's being offered at a discounted rate. I have some more information for you that will be a part of the PDF that I send out, but you'll find everything that you need to know at that website. The thing that makes the Tree Asset Manager good is you can do more than one tree at a time. So you just upload an inventory with the species and the diameter and the location, the general location of where the trees are going to go, and it does all the calculations together for you. Unfortunately, it's missing the ability to calculate the energy benefits. So if you are planting your trees strategically to reduce energy use, that's going to be something that you really do want to calculate. If you're not, let's say you're planting your trees along a trail or on a big abandoned piece of land or something like that, or even in a big park where there's not much, where there aren't very many buildings to be shaded, then you might not care about this energy benefit, and then the Tree Asset Manager tool might be a good one for you. And finally, iTree Design is also a web-based tool from Davy Resource Group, and their collaboration with the Forest Service uses the same data. Sorry, I'm just getting a note to tell me to go a little more slowly and wait for the slides to load. So I'm gonna remind myself to do that. iTree Design, a web-based tool. You'll draw an outline of your house. You'll put the trees in their location. I also found some missing data in this one in a not predictable way, and it does not show you the total carbon storage. So it also has some missing bits. Again, they all have missing bits. They're all a little bit quirky in their own way. I've chosen today to focus on the tree carbon calculator because it's the one that I can consistently explain to you when it's quirky how to fix it. And I know that the data that you get will consistently be available. You won't ask it for something and get a number that is wrong. So that's what we're going to dive into right now. Let's get started. So you're going to go to that website. It's just an Excel file. We're going to download a zip file from the CAL FIRE website. The zip file is right here. You unzip it, you get this big folder. And then all you want here is the Excel file itself. The first thing it's going to ask you is, do you want to disable the macros before opening the file? And this looks really scary because it talks about viruses. Yes, you want to enable the macros because that's what makes it work. I promise you there are no viruses in this file that you're getting from the government. And the very first thing that happens when you click on Enable Macros is you get a bug. Luckily, this bug is really not important. All it's telling you is that for some reason it can't access the welcome screen. And to be honest, this might be a Mac-specific problem. It might be that if you have a PC, this doesn't happen. But if it does, you don't care. You just say end, and you go on. And what you get looks like this. So I'm going to wait a second because I know this is a bit of a heavy image, and I want to make sure that it has a chance to load. It's got three main components here. We've got the project input data. We've got the tree input information. And finally, we've got the outputs. And I'm going to talk about each one of these in great detail so that you have every step along the way and you know what to do. So very first thing, these are the project inputs. I don't know why the wording on this is so obscure. It really didn't need to be, but that's why you're going to have this manual. So the very first project input is asking you if you want to input the DBH of the trees or the age of the trees. And because this is a time-based project, since we're looking at a 40-year project horizon, what we care about is the age of the trees and not their DBH. So we have two choices. We enter 1 if we want to use the DBH. We enter 0 if we want to enter the age. And so we're going to enter 0 in there. And so here is your little hint. These aren't really hints. These really are rules, but that didn't seem very friendly, so I'm calling them hints. So in the first box, we definitely want to enter 0 to use age. The next project input is shade versus climate. So we said that one of the benefits that trees provide is as they shade a building, they reduce the energy use of that building. So what this is asking us is do we want to do shade or shade and climate? And I didn't even talk about the climate effect, because the truth is you have to plant a lot of trees for the climate effect to really kick in. You need to change the percent canopy cover of your region for that to happen. I think most of us know about the urban heat island effect, where it's hotter in cities than it is in the surrounding area. And we are aware that if we plant a lot of trees, we can actually lower that. We can reduce that urban heat island effect. Even we can actually reduce the temperature of the city, even when you're not standing right under the tree. But again, you have to plant a lot of trees, way more than a couple thousand in order for that to happen. So my advice on this case is to enter 0. We're just going to use shade. The climate benefits aren't very substantial. So for the sake of being as conservative as possible, we're just going to use the shade only. All right, the second project input, or the third project input, is your climate zone. There are 16 climate zones in the country and 6 or 7 in California. How do you know which one you're in? Well, we have a couple of ways. Well, we have one good way of figuring that out. This is the map that the original climate zones that reflects the climate, the original map that reflects the climate zones. The trouble is, in California, you can see, especially down there in Southern California, it's pretty hard to figure out where you are. Unfortunately, there actually isn't really much of a better map. I think there's a GIS version, so if you have access to ArcView, I can help you find a way to get that map, but this is not an easy solution. Still, I also managed to come up with, from an old document, this one that shows Southern California a little bit more zoomed in. Has older names for the climate zones, so I have some translations down here below the map showing what they are into the new version. And then here's the source for the map itself, if you would like to get that document so that you can have a look at it. From an earlier project, the LA tree map, I happen to know that in LA County itself there are 4 or maybe even 5 climate zones. So if you're doing a project that covers the entirety of LA County, and the same is actually true for San Diego County, the benefits are going to be different depending on which climate zone you're in. But you could go crazy if you're trying to incorporate all 5 climate zones. And I think you will get more accurate results if you stick with 1 or 2 and make use of those. Even if your trees are planted slightly outside of those, I would say if you use the data for the Southern California coast and the data for the Inland Empire, you're probably going to get your most accurate benefits in Southern California. We can talk more about that later on if anybody wants to. Okay, so back to the project inputs. You choose your climate zone by just selecting one from the list. Okay, next are the emissions factors. You don't really care about this. These are default, they're regionally based, and essentially what they represent is, so to speak, how dirty your energy production is. Most of our energy in California is actually quite clean, so these numbers are not as bad as they would be, for instance, in a place where most power comes from burning coal. It's highly unlikely to me that you would be able to get better numbers than these. So we're going to actually just stick with the defaults in this case. Leave them as they are. Okay, so that was the project inputs. If your project takes place in one climate zone, you will not have to make any changes to this from now on. If you've got more than one, you're going to have to do all these things for the first region, go back up to that climate zone thing, change it to the second one, and then do everything again for the species that get planted in that second climate zone. Because the climate zones affect the species that are available from the list, the way the trees grow, the emissions reductions that are associated with them, right? So if we plant a tree in, say, San Francisco, it's not going to provide us the same kind of energy conservation benefit as a tree would if we were planting it in Fresno. So if your project is in one climate zone, you're now done with that top box. What we're going to talk about now is how we calculate the benefits for carbon storage. So assuming that your project has nothing to do with energy, this is all you're going to have to do, and it's going to be pretty easy. Once I'm done with this, we'll come back to the energy because the energy one is substantially more complicated. But the carbon storage piece is really straightforward. So we are going to dive into that.
Kelaine, we do have one question
that
you might want to take into account as you're going through this. From Drew Reddy, he says, our Green Innovations proposal is for green infrastructure / stormwater management projects that include a tree but also other plants. Many large shrubs, for instance, have known greenhouse gas benefits. Do any of these tools calculate greenhouse gas benefits for shrubs and other plants?
Fair question. To the best of my knowledge, there does not exist a tool anywhere that calculates greenhouse gas benefits for shrubs. As far as I know, that is the case. So it's not that the data couldn't possibly be out there, but I think you'll probably have to go looking for it in the scientific literature.
Great. Thank you.
Sure. Okay. And let me also say, I guess it depends on what you mean by a large shrub. So sometimes, I'm originally from the East Coast, and I was really surprised when I came to California to find that there are a lot of things that really are shrubs that we prune into trees, like camellias. So there's definitely data, and I'm looking in my backyard right now at a Ligustrum sinense. That's actually quite a pretty decent-sized tree. So for those kinds of quote-unquote shrubs, the data is available. But if you're talking about something that doesn't get higher than, say, waist high, as far as I know, no such thing exists. Maybe if somebody does know that, they can chime in. I know CAL FIRE is trying to build a database of sources where we can get this kind of information. So if you have it, if you find it, please share it with everybody. That would be great. Okay, so here we are, calculating carbon storage only one tree at a time. So the very first thing that we have to do is enter the species. Here is the list of species. I think this is actually the Central Valley climate region. And now I say, oh my gosh, that's only 20 trees, and I don't like any of them, and that's not what I wanted to plant. And that's fine. The truth is there are not that many growth curves out there in the world. There are not that many carbon equations for trees out there in the world. And so this is sort of the best that's available. I want to be clear that all of these products that I talked about before, the Tree Asset Manager, EcoSmart Landscapes, iTree Design, all of these have the same limitation that in the background there are only 20 or 25 species being used. It's just hiding behind a curtain in those other cases. And here it's in your face that you're actually going to have to you're going to have to match your desired species to one on this list. And I'm going to show you how to do that right now. So there's just another explanation. And here's my little note at the bottom. Please don't limit your project trees to the ones on this list. There's no benefit to that. And in most cases, these were the 20 most common species in a region, and that's why they made for the best data collection. We definitely don't want this project of $17 million to decrease our species diversity. So don't feel at all limited by this list. I'm going to show you how to make use of it, and it's not a problem at all. All right, so there are some resources and some rules that we can use to match the species we want to plant to the species that is available to us in the tree carbon calculator. The first one comes from the iTree suite of software tools. You can just click on this link, and it's going to be another Excel file, and it looks like this. So down at the bottom, you see my little arrow that says pick the right region. Make sure you're looking at the right region. These are what matches with another species in one region can be quite different from what matches with it in another region. The way trees grow is really different from region to region, so make sure that you've chosen the appropriate one. Then column B, where it says scientific name, is where you would find your species. And then in column E is the matching species code for the tree carbon calculator. So let's get a little bit deeper into that. Let's say that you want to plant the Chinese elm, Ulmus parvifolia, and it's not one of the 20 species on the drop-down list. iTree tells you here, if you look in the far right column, that it matches to something called ZESE. ZESE is the code. It's actually in the tree carbon calculator, but if you're curious, you can actually follow that code back over here and see that ZESE is the Zelkova serrata. So that makes some sense. The elm and the Zelkova are in the same family, and they grow fairly similarly in the same sort of shape and at the same rate. There is the little explanation for you. Now let's say you want to plant Sorbus hupehensis, which I don't even know what that is, but I really like the name. Now, in the right-hand column, it says BDS other. What does that mean? Well, it's not something that's on the list from the tree carbon calculator, except in an indirect way. So this is like a double match here. Now we have to look up what the BDS other is. And that just stands for broadleaf deciduous small tree. And when these species matching lists were put together, it was decided that if you couldn't make a better match and your tree was small and broadleaf and deciduous, you would match it to LAIN, which is the Lagerstromia indica crepe myrtle. So if you're planting Sorbus hupehensis, you would go to the tree carbon calculator and choose from that list the Lagerstromia indica. I hope that makes sense. I think it'll make sense once you see this more slowly, but there is the explanation again. So that's your first choice, because then you don't have to do any kind of thinking. You just look up what the Forest Service how the Forest Service has matched these together, and you go from there. If the species you want to plant isn't on that list, then you look for a species on this list of 20 trees that is of the same genus, say. So let's say my vision is to plant Quercus lobata. What on this list matches with that at the genus level? Well, we have Quercus ilex. Seems like a pretty fair combination to me. Those two seem fairly similar. I'm going to go with that. What if there's nothing from the same genus? Then we're going to look for a species of the same family. It'll be the same thing that sort of happened back there with the elm and the Zelkova. You'll just have to do it yourself. So let's say I want to plant Malus domestica. I'm going to plant some apple trees. Then my best choice on this list is probably the Pyrus Caleriana. It's a small kind of fruit tree, both of them in the rose family. Now, you have to be reasonable about this, because sometimes the family makes a lot of sense. Like all those trees in the rose family, the apple, the pear, the prune, the plum, the almond, we can see they're all quite similar. Sometimes the species, even inside of the same genus, don't have that same kind of connection. So if you're going to plant Japanese maple, which you shouldn't be because you're not supposed to be planting small trees for this project, but if you're planting Japanese maple, it's not going to be a great match to mix it with Acer saccharinum, which is a gigantic tree that grows really fast. So use some judgment here and match the Japanese maple to another small species. That would be much more appropriate. So if none of those options is available to you, then you're just going to choose a species with a similar type, whether choose one that's broadleaf or a conifer. Look at the mature size of the tree, like we just talked about with the maples, and then look at the leaf habit. Is it deciduous or evergreen? So let's say I want to plant Eucalyptus globulus, and I kind of just don't pay any attention to these species that I'm choosing because a lot of them would be really bad choices. There's no eucalyptus on the list. There's nothing in that family, but my tree is very, very big, and it's an evergreen, and so I'm going to match it to another big evergreen on the list and use Quercus ilex as my matching species. So then, to sum it all up, choose a species that's most like yours from this list. Okay, this one's complicated too. Age. We're going to enter the age of the tree in order to figure out the carbon storage at 40 years. Now, you would think that we could just type 40 into this box and we would get an answer. The problem is, depending on the species, some species grow really fast in the early years. Some grow really, really slow. So the tree that you're going to plant, which is probably going to be about a 15-gallon tree according to the grant guidelines, has a couple years under its belt already. And the growth curves are a little bit wonky in the early years anyway. So my suggestion here is to start by entering the year number 1 in this box, and then look to the right, and it tells you what the DBH, and I see that there's like some, maybe there was a question about what DBH stands for. So for the non-tree geeks out there, that's the diameter of breast height, and that's usually how we talk about the size of a tree, the diameter of the trunk at breast height. So start with a number 1 in this box, and then watch the DBH value change until it gets to about 1 or 1.5 inches, which is about how big we would be planting that tree. Or if you think your tree is going to be 2 or 3 inches in DBH when you plant it, then look for that DBH. And then that's going to be that's your project year 1. So I'm highlighting the ginkgo here because it's a really slow grower in the beginning. And by the time we plant it at 1.2 inches, it's already 7 years old. So when our project is over at 40 years, the tree is going to be 47 years old, and we would have lost 7 years worth of benefits if we just put 40 in that box. So what I'm saying here is figure out the age of the tree when you plant it and then add 40 in order to get the right project length and to demonstrate the highest number of benefits possible while being honest about them. So here's an explanation for you when you take this home. And play around with this yourself and you'll see what I'm talking about. Many species, when you put 1 year in there, it already says 1 inch DBH, and so all you need to do is add 40 to that and you're fine. All right, so that was the project inputs, and then the individual tree input, and then we get an output. And it's just this tiny little guy over here in the far right corner in the box called total CO2 stored. Let's just get a little closer to that. So if I blow that up, I see there's 3 columns there. The middle column is the one that we want. The total CO2 stored, that tells us, wait, oh, sorry, let me go back here because I realized it wasn't very clear about this. Back here, we figured out that when our tree is 1.2 inches, between 1 and 1.5 inches in DBH, it's 7 years old. Now we want to know what happens at the end of the project. So what will our tree have done over that 40-year period? So the thing we're going to put in this box is 47 for the ginkgo. In other cases, it might be 41 or 45, but we want it to be 40 years after the age at which it reached this DBH. Okay, sorry about that. So here we have the inputs, and you can see there's the ginkgo, and there's the 47-year point, which is 40 years after we planted the tree. And you can ask me more about that at the end if I know this is not straightforward. Okay, so back to this. The total CO2 stored then is how much has been stored in that tree at the 47-year point, 40 years after your project started. In the grant guidelines, we're asked to represent these numbers in metric tons. So the number you want to take note of is the one that represents kilograms. We want to use the metric system here because that's what we're being asked to do in the end. So total storage for the project lifetime. And remember, we talked about sequestration being the process, the annual process of adding more carbon bit by bit. So this is what happened for the tree in the last year, over the last year, are these numbers. So don't get them confused. This one you don't care about at all. This is a little bit for more scientific uses. It just distinguishes what's happening above the ground from the roots of the tree itself. Okay. That was calculating the storage. So not actually so bad once you've understood all of that. You just put in the species, you put in the age, and you get your number out, and you're done. Calculating the energy benefits is a lot more complicated. And that's what we're going to talk about, the inputs, this entire box of inputs for calculating the energy benefits. And then on everything else on the bottom are the outputs that are associated with that. Ashley, just let me know if I'm going too fast as the slides switch here, since I don't have any sense of how long it's taking on the other end. Okay.
It seems like everything is fine. I'm not getting any more messages about audio problems.
Okay, folks, if it's breaking up because I'm not waiting long enough after the slide loads, let Ashley know and she can tell me. Okay. So now we're going to put something in each one of these boxes. The species happens exactly the same way as it did before. So that should be the same. Now, the tree inputs for the age. Here's the challenging part in this case. The energy benefits are only calculated 1 year at a time. So the tedious thing is if we want to look at them for 40 years, we've got to do each year individually and record those outputs and add them all up. I wish there was a different way to do this. Unfortunately, none of the existing tools really offer that capability. So one advantage of the tree carbon calculator is it's the easiest to get that data out in a way that you can just copy and paste it, and I'll show you that in a minute. Okay, so we're going to go back to project year 1, and with our ginkgo, remember that was a tree was already 7 years old in project year 1 because that's what the point that it reached this diameter. So we're going to start with that one. And here's your hint, each year must be input 1 at a time. All right, the tree.
Jump in here really quick with one quick clarifier. We have a question that says, grant applications ask for greenhouse gas sequestered, not stored. Are we using those terms synonymously? The RFP that I looked at yesterday asked just, if I remember right, for 3 numbers: the total storage over the whole lifetime of the project, the total energy over the lifetime of the project, and then how much carbon is emitted in taking care of the trees. So I'll have to go back and look at it. I think they are kind of synonymous. It's really just a question of whether you're being asked to show every year at a time, which I don't think we are, but we can actually capture that very easily anyway. If we want to show 1 year at a time, we would do it one way. If we just allowed to show the total for the project, what we call storage, okay.
Cindy's
looking at so it's CO2 stored by trees.
Yeah.
So total.
Yeah.
Okay. Thanks for the clarification.
Yeah, and let me just say that this use of sequestered to talk about what happens on an annual basis and stored to talk about what happens in the whole tree is really made up by the urban forestry community. So in real life, those two things are in fact synonymous. I'm just trying to keep them separate, but it's very possible that in the grant application itself it mixes them up. It's just a question of what the number that they're asking for is at the end. If they want to know every year, if they want us to show our work year by year, we can do that too. That's not a problem at all. We would just capture the number for sequestered instead of the number for stored. Okay, so back to calculating the energy conservation benefits and the associated greenhouse gas benefits for trees that are planted to shade buildings. So there's 2 important factors in figuring out how much work the tree is doing. One is which side of the building it's planted on, and one is how far away it is. So the first question is, on which side of the building is the tree planted? And the reason I'm showing this picture is because, in my experience, people have gotten this backwards. So the building is in the middle. This tree is to the west of the building. So here we would choose west as our option, number 7. And this tree is to the south of the building, and so we would choose south. I hesitate to even mention the way people get confused, because I don't want anybody to get confused. But sometimes people have a tendency to look at the tree and ask where the building is. So just come back to this little drawing and know that in this relationship, the west is what you're looking for and south is what you're looking for. Okay, so for the tree on the west, we're going to choose number 7 here. That's the azimuth equals the direction from the building to the tree. There are no shade benefits for trees that are planted on the north or northeast sides of the building. They don't block any sun. So if you're planting trees there, just skip this whole part. You're going to be wasting your time. You're just going to get zeros, and it's going to drive you crazy. So that's an important thing to keep in mind. So the hint here is which side of the building is the tree on. Okay, then the next important question is how far is the tree from the building? So if the tree is 3 miles from the nearest building, it's obviously not going to shade that building, and we can't count it. In fact, unless it's in the first 3 categories, if it's got to be less than 60 feet from the building, or no shade benefits are going to be associated with it either. So again, if your tree's farther than that, don't waste your time doing this tedious work because you're not going to get anywhere. Okay, now this is where it gets a little bit weird. There are 3 more factors that affect the relationship between the tree's shade and the building itself. One is the building vintage. So the older your house or building is, the less likely it is to have double-paned windows and modern insulation and all the kinds of things that keep wind from like howling under the door like in my house. The problem with this is you're not going to really know this, I don't think, at this point in the project. You're not going to know exactly what kind of buildings the tree is around. You're not going to know whether, even if the building is from 1900, it has been completely redone so that it reflects more modern energy conservation benefits. And every time you change one of these things, you have to redo the whole 40-year project for each change you make. So let's say you were going to plant all ginkgos, and they were all going to be on the west side, and they were all going to be 20 to 40 feet from the building, but the building that they're going to be next to could differ in age. You're going to have to do this whole process for all different building vintages. And the number of possible combinations when you take into account the tree, azimuth, and the distance class is enormous. So my recommendation to you is going to be just choose 2. I think it reflects a relatively conservative estimate, and it's going to balance out between the fact that some of the buildings will be older and some will be newer without us all going crazy and losing our minds. Just to reiterate, I'd actually say the same. I'm going back one here to the tree distance class. I think I would say the same in this case. I would say just call them, unless there's a reason that you know this isn't going to be the case, call them all category 2. In most cases, you don't really want to plant a tree too much closer to a building than 20 feet, especially when you're in a fire zone, or just because you get into all those conflicts between trees and houses. But again, the ones that are planted closer and the ones that are planted farther will average out, I think, over time. And if you just choose number 2, you're going to have a conservative and fair estimate, and you won't go crazy with all this busy work. All right, so building vintage, we're going to call it 2. All right, this one we're also going to pick one and stick with it for the whole project. What kind of air conditioning equipment does your building have, and what kind of heating equipment do the buildings have? I think in most cases, the kind of buildings we're going to be talking about where the shade is going to be relevant are going to have central air or a heat pump. And then in most cases, they're going to have natural gas for heating, except they might have a heat pump too. In this case, you talk to me about this individually, because it could get really crazy, and I don't think it's going to make that big of a difference in the end with the results. So unless you know that every house in your town is heated with a heat pump, stick with number 1. And finally, these are the default values. I would also stick with these. They're specific to natural gas heating. So if you're going to go with the heat pump route, you could talk to me about that as well. But just the short story is leave these as their default options. You might be slightly interested to know why the electricity emissions factors were at the project level all the way at the top of the screen, and I said leave those at the default. And then the heating emissions factors are on the tree-specific end of things, and that's because in most cases, most people don't realize this, but you're actually creating those greenhouse gas emissions in your own house. Every time you turn on the heat or make some hot water if you have a gas hot water heater. So those are things that they are in fact specific to the tree, because it depends on what you're burning in your own house in order to heat the house. So kind of interesting. All right, leave as is for natural gas. If you're interested in using a different kind of heating equipment, let me know and we can talk about how that would work. Okay, and finally, the avoided CO2 and energy conservation outputs are at the bottom, and they are the 1, 2, 3, 4, 5 columns on the left. Everything that's not the things we talked about before. So I've cut and pasted that, and so we can dive into that a little bit more deeply. So remember, this is project year 1. Our ginkgo is 7 years old, but it's in its first year. It's 1.2 inches in diameter, And here are its energy benefits. It reduces your energy use for electricity by a minuscule 1.6 kilowatt hour, which is approximately 10 cents worth of power. You don't care. This is not important, but we're going to capture this anyway because it's a long way to that 40 years. Heating. Here's what the effects the tree has on heating. So as we plant our trees to provide shade, they can also shade us in the winter. And that means that sometimes a tree will actually increase the amount of heat that we need to use to heat the house. This number, especially in California, is really small in comparison to the benefit that we get from the shade. So it's a negative number because it actually is costing us a little bit of heat every year, but it really is small in comparison. Nevertheless, we're going to account for it as well because we want to be honest about our benefits and costs. So that's the first two columns. And then in the next three columns is how that translates into reduced greenhouse gases. So by saving us 1.6 kilowatt hours of electricity, we've cut the amount of greenhouse gases produced by 0.6 kilograms, or about a pound, or 1.4 pounds, I guess. We've caused a little bit of emissions to be created because we are blocking some winter sun, and that's causing our heating use to go up. And the total number here, and this is because of rounding problems, is, so this is probably, just ignore the fact that these don't really add up. This is because these numbers are rounded, and so the total is showing up rounded as well. So this is the total greenhouse gas benefit, accounting for the good things that the cooling does and the bad things that the heating does. And here's the explanation of all of those things. We want to capture, again, this metric one because we're being asked for the calculations in metric tons. We'll translate those kilograms into metric tons.
Kelaine, before you leave this page, you're about to give a hint. Finish up this page, and then I've got a couple of questions for you.
No, go ahead. The hint is good.
Okay. We have a couple of questions about street trees. So the first one is, I plan on planting a street median. Is there a heat calculator for roads, or do we ignore that?
There is not a heat calculator for roads, so that would come into those climate benefits that we were talking about, which are really small and which really only come into play when you're planting a lot of trees. So if you're going to plant 50,000 street median trees, that would be something that it might be worth calculating those climate benefits for to capture them. But the short answer is no. One thing you might keep in mind is that there are benefits associated with improvements in the pavement quality when you shade the road. And there are some things you could include in your narrative, some co-benefits that you couldn't put a number on, but you could talk about how the road would, there's research talking about how the road would last better. The pavement will need to be resurfaced less often. You can talk a little bit about air quality benefits, though again you can't put a number to them. And I'm going to, at the end, I've got a list of the community tree guides, and they talk very detailed about some of these co-benefits.
Okay. And I think that probably ties in very closely to the second question, which is, what if the project reduces vehicle trip and emissions by creating a needed neighborhood amenity? Can this be calculated for the grant application? So it sounds like that page that you have later on has some of that information.
Well, that's a question that doesn't have anything to do with trees, if I'm understanding right. That question says, just as an example, let's say I'm going to put in a neighborhood park where people used to drive to the county park. Now there's going to be a park where they can walk or ride their bikes. How can I figure out how that reduces their vehicular miles, and what are the greenhouse benefits associated with that? And again, there's definitely not a tool that I know of that will tell you that once you've figured out your vehicle miles reduced, and I have no idea how you do that, but if you've done that, then it's a really straightforward calculation to figure out how much less gas is being used and what the reduction. Once you have a number of vehicle miles reduced, it's easy to get to the greenhouse gas benefits. It's going to be finding that vehicle miles reduced number that's going to be tricky.
Great, thank you.
Yeah. Okay, so if we go back here, these are the benefits in project year 1. So now what we have to do is we have to go back to the inputs and just change that age of the tree from 7 to 8, and we get a new set of numbers down here, and we capture those, and I'm going to tell you what that means in a minute. And then we put 9 in the box, and we capture those. Then we put 10 in the box, and we capture those, and we put 11 in the box, on and on and on and on, until we get 40 years worth of numbers under our belts. So repeat for all 40 years, copying and pasting the row that I have highlighted in red here into another sheet. And now we get to something messy. When I went to the workshop and then in the webinar, the CAL FIRE webinar, they showed this slide with the suggestion that this is the output. This is an automatic output from the tree carbon calculator. Sadly to say, it's not. This is a template. Just a suggestion of how you might capture the information yourself. So here's your hint. This is just a template. You should build your own because it doesn't really capture what we want it to know. So I built one that makes more sense for us, and you can just make use of it's not like you just have to rebuild it yourself, but it's really easy to rebuild it yourself. You just use this as a template to do so. So here are the important parts of this. Number 1, you need one of these worksheets for every unique combination of species, azimuth, and distance, right? Because if we plant the tree on the west or the south, it's going to have different benefits. If we plant it near, adjacent, or far, it's going to have different benefits. Again, I suggested that you just call them all near, and I really think you should stick with that. But you do need to be, I think as far as the azimuth goes, you need to be, that one is pretty important, so we need to be quite specific about that. So build one of these sheets for each one of those combinations. Then in the left-hand column is the age of the tree that you entered, and next to it is the project year. And then in the next 5 columns are the numbers that you cut and pasted. Just the advantage of copying and pasting is it's much harder to make mistakes. So even though we don't necessarily need all these numbers, if you copy and paste the whole row, it's going to go a lot faster for you. Then these numbers are made up, so don't pay attention to them. But we go all the way down to project year 40. We've done all 40 of them. Then in the bottom row that's labeled with number 4, we just do a sum of all of the numbers above it. So in this made-up example, over the 40 years, our little ginkgo has reduced the amount of cooling energy we need to use by 482 kilowatt hours. Now that number is not correct, so don't think this was worthless because that's just a tiny amount. The number will be much bigger than that. It has cost us some heating to the tune of about minus 0.14 megabTUs, which is a really small amount, so we really don't care about that. The next thing over are emission reductions, the ones associated with the cooling, the ones associated with the heating, and then the 2 of them put together. And that number that's highlighted in yellow is the only one you really care about. It's the one that CAL FIRE is asking for specifically. But I think it's good to have just captured all of these because our values for cooling and heating reductions, the energy reduction numbers, are going to be great co-benefits that we can talk about in the narrative. So capture it all, but the one number that's specifically being asked for is that one in the bottom right that's yellow. It's this total 40-year summary of all the cooling and heating emission reductions.
Kelaine, we just had a clarification question really quick.
Yeah.
Catherine Martineau wanted us to confirm which azimuth creates benefits. Is it west and east or west and south? Only those?
It's all of the azimuths will have some benefits associated with them except for the north and the northeast. The most benefits are going to come on the west and the east, but you will get benefits for the other 6 cardinal directions other than north and northeast. And keep in mind that if you're planting a tree next to one let's just say you're planting it next to a house in your neighborhood, and maybe you're planting it on the north side of your house, you're actually planting it on the south side of someone else's house. So it doesn't have to be the house that's associated with it in any way. Just you're going to pick the azimuth that best reflects the tree itself, like the work that it's doing. You want to show it to its greatest advantage. That's a totally reasonable way to think about it. So that's not cheating or anything. Okay, so I'm going to go back here just for 1 second. Remember our number down here was 405. So this is the second part of the template. Here was my Ginkgo biloba tab, and now here's an all trees tab. And here's the one that we were starting with, Ginkgo biloba on the west, near, and that was our 405 number. This was the number that we came up with when we did that carbon storage part of the project. And now I'm going to say we're going to plant 100 trees like this, 100 ginkgos to the west of buildings within 20 to 40 feet. So the total emissions reduction, what's in G here, is this number, the emissions reductions for one tree over 40 years, times 100, and then we've been asked to have it in metric tons, so it's just divided by 1,000, because there are 1,000 kilograms in the metric ton. So 405 times 100 divided by 1,000 is 40.6. And then in this made-up example, I've done the same thing for a ginkgo on the west that's close. Here's a ginkgo that's not shading a building at all, so it gets the carbon storage benefit, but it does not get any emission reductions benefits. And note, since these are all ginkgos, they're always going to be the same. This number at the 40-year carbon storage number is always going to be the same. And then here's just a different made-up species to the west and to the east. Again, it's both red maples, so they're both going to have the same CO2 storage, but they're going to have slightly different emission reductions values because they're planted on different sides of the building. And then I can't figure out how to make this webinar panel scoot over, so I actually can't see my own. Oh, there we go. Okay, so I couldn't see column H for myself. So then we sum all of these up, and then this is the total project. So this is for 200, 700, blah, 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 1,250 trees or whatever that is. They will have reduced the emissions by 318, and they'll have stored 3,800 metric tons of carbon. And those are the two numbers that were being asked for on the grant application. So it took us a long time to get here, but it definitely is possible using the tree carbon calculator. So that's pretty much the tree carbon calculator. I wanted to talk about one or two other things in my last, I got about 4 minutes here before we turn it over to questions. I mentioned co-benefits a couple of times, and I think that your grant proposal will be made a lot stronger if you can talk about the other kinds of benefits that trees provide. So we have, I'm going to go back a little ways here. Again, remember, we calculated these co-benefits ourselves for the cooling, for the reduced energy, and possibly reduced heating. Sometimes it's positive, sometimes it's negative. But we can definitely talk about the benefit in terms of energy conservation. Completely outside of the greenhouse gas question, it's very advantageous for us to reduce our energy use. Of course, we go through all kinds of crazy things like using different light bulbs in order to do that. A tree is much more efficient than swapping out your incandescent light bulbs for fluorescent ones. So that's a really, really valuable co-benefit. Some other ones include stormwater, filtration, air quality improvements, improvements in property values. So some of those accrue to the homeowner, but some of them accrue in the form of higher property taxes to the community. So if you can improve the value that people get for their home and it sells at a higher price, then the community is going to see a higher value in terms of property taxes. So that really, there is a community aspect to these property value benefits as well. And for that, I'm recommending the community tree guides. And in the back of every community tree guide, and on the next slide is a link to each one that's relevant for California, is a table that looks like this, that shows the annual benefits at 5-year intervals and the 40-year average for 3 different kinds of trees, a small one, a medium one, and a big one. So because this isn't really what the grant's about, you shouldn't go crazy and waste a ton of time doing this. What I would suggest is you come to these tables, you pick either the medium or the large, depending on what kind of tree you're planting. And I think we're staying away from small. The grant application asks us to plant trees that are only bigger than 25 feet. So we'll look at the medium or the large. And then just look at this 40-year average. So we don't need to use the heating and cooling ones because we actually did this specific for our actual tree. So we definitely don't want to use those. We don't need to look at these carbon dioxide benefits because, again, we have specific ones for that. But we can go down here and we can look at the air pollution numbers, and then, sorry, the table got cut off. There's a number for air quality, there's a number for stormwater, and there's a number for property value benefits. And I would just take that 4-year average, multiply by 40, because there's 40 years in our project, and then multiply it by the number of trees that are either medium or large, and just be able to say, hey, these are not exact numbers, but we think these trees are going to provide approximately this many benefits in terms of stormwater and air quality and property value. And then if you want to dig a little bit deeper to the things you can't quantify, in those community tree guides, you'll also read about things like I mentioned before, improvements in pavement. So can we resurface our roads less often if they're shaded by trees, which manages to protect them? If we're planting trees over a parking lot, they actually have significant air quality benefits because a lot of pollution is created by cars when they're sitting, not running, in a hot parking lot. So you'll learn a lot about those kinds of things, and you can talk about them even if you can't give the numbers. You can say the air quality benefits of my tree over a parking lot are not just ones that would accrue to any tree in the city, but they are substantially greater because I am cooling these cars. And so the pollutants are not evaporating out of their gas tank at the same rate. So a lot of great details in the community tree guides. Don't just look at your own. Here is the list. The most recent one is the Northern California one, and so I would say have a look at yours. Some of these are quite a lot older. Some of them are even, I think, 15 years old now. But have a look at your own, and then have a look at the Northern California one, because it's going to have the most up-to-date research, and it might give you some ideas about things that have happened in the meantime, maybe things related to public health. Definitely that research about road surfaces, and some other things I'm sure I just can't think of off the top of my head. So again, these links will be live when you get the PDF, so you can just click on them to download these community tree guides. And then I don't have a lot of answers about this, but I wanted to throw one thing out there. The third number that we're being asked for, so we're asked for the carbon storage total, for the avoided emissions total, and then we're asked to estimate the emissions associated with tree care. Right, so when you go to plant these trees, you're going to drive a truck. Depending on where you are, you might need an auger to drill into the soil. You might need some heavy equipment. When dead limbs fall to the ground, maybe they're getting chipped in with the things that run on diesel fuel or whatever. So we're being asked to estimate that, and there isn't, as best I know, there's no really good source on that, and you're going to drive yourselves crazy if you try to figure out. I don't even know how you could start with that, and I don't know that anyone really expects you to make a wildly accurate estimate. So I found this quote. It's from the community tree guides. I think they all include it, and it references this particular paper and says that generally speaking, the CO2 released in tree maintenance is about 2 to 8% of the total reductions obtained through sequestration and avoided emissions. So we can add our two other numbers together. We can add our carbon storage number and our avoided emissions number together, and then estimate that the CO2 that we're putting out into the atmosphere to tree care is about 2 to 8% of that. Now, how do you decide between 2 and 8%? I have no idea. Maybe that's something that we can get some guidance from CAL FIRE on, or maybe that's something where we can show our work. So let's say you live in an extremely compact city, a very dense place. Maybe it's in San Francisco, and you know that to get from one place to the next, you're not going to have to drive very much, and who knows, you have some kind of crazy electric hybrid chipper. So you're going to go towards the smaller end of that number. Let's say instead your plan is to drive your own truck to a region that covers 100 miles from north to south and 50 miles from east to west. You know there's going to be a lot of driving. Your plan is to drive from tree to tree and water them every week. Maybe you pick a number that's at the higher end of that range and just use the narrative to explain, to justify your choice. Seems like a reasonable solution to me. Unless, if anybody has any better ideas about this one, I would really look forward to hearing them. But I came across this last night, and I thought, well, at least that's a place for everybody to start. So on my end, that's it. I'm ready for any questions you might have. And I'm just going to remind everybody, after this, I've got one more slide that talks about the webinar that's coming up this week on Thursday from CAL FIRE, where they're going to talk more specifically about the grant application process itself and not about tools and calculating greenhouse gases and stuff like that. So if I don't have a good, if I'm not the right person to answer your question, I'm just going to point you in that direction so that you can get your answers there. It's not, you don't want me to answer those questions. So, all right, what do we have, Ashley?
All right, so just a tip that we have been given going back to the greenhouse gas impacts for shrubs, just a comment that perhaps CAL FIRE did something in their vegetation management program and the environmental impact report, there might be some information about that there. So people might want to take a look at that who had questions about GHG impacts with shrubs. Next, let's see, you've covered that. Can you just briefly go back over how you know the age of a container tree?
Well, this maybe somebody else can jump in with this, but my idea is that a 15-gallon tree is usually about an inch or an inch and a half in diameter. If that's not true, then just swap out whatever number I'm saying here for something else. So what you're really looking for is to just go through, hang on, one second here. I'm going to go back to my slide.
Perfect.
That, where I show the numbers hop around. Okay, see right here, it says in row 21, it says the age in years is 7, and the units are years because we've chosen up here that we're going to talk about tree age. And then in this box, it says 1.2 inches DBH and 9 feet high. If I put 6 years in that box, this number is going to go down, and it's going to be below 1. It's going to be below 1 inch. If I put in 5, it's going to be even smaller. So these numbers actually change as the age of the tree goes up. So all I'm looking for here, my start point, is a tree that's about 1 to 1.5 inches in diameter. Now, if your project envisions planting bigger trees than that, let's say you've had a really bad problem with vandalism, or people just don't see your trees and they run them over, so your vision is to plant trees that are 3 inches in diameter at the project start, then you're just going to change this age. You're going to go up year until this number says something closer to 3 inches. And that way the project, the 40 years from that point, you're actually getting to capture all of that benefit instead of, if you just put in 40 years there, you'd be missing out on a lot of value from that tree because it's actually significantly older by the time you get to 40 years for the project. I hope that makes sense. If it doesn't make sense, just put 40 in there. It's fine.
All right, so our next question is from Nancy Sappington, who had to leave the conversation, but I'm still going to ask it so that it's on the recording here.
Okay.
She wants to know how much of this is relevant when you're preparing proposals for urban forest management plans, urban tree cover, and tree inventories. She says, at the end of those processes, we would know how many trees we've projected to be planted, but the actual knowledge of such will not be known when preparing the proposal for the grant. So how should these requirements be addressed?
I think that's a really good question. I really think that's one that is better directed at John Melvin. I think there are ways to talk about how a tree management plan has the potential to increase your greenhouse gas benefit, but I don't know how, as Nancy says, in the absence of having actually done the plan, it doesn't really, you don't have enough information without making some big leaps to do those calculations. So maybe CAL FIRE can weigh in on Thursday and help us to figure out how we could think about that.
Great.
Sorry. I agree.
Next question from Amy Augustine. She says, generally, are there guidelines for best CO2 storing trees? Broadleaf, compound leaf, evergreen, deciduous?
Great. I actually meant to say that, so thank you for that question. Perfect. Generally speaking, the only thing the most important thing you care about is size. So like we said, the tree is pulling CO2 out of the atmosphere and it's turning it into tree stuff. The bigger the tree is, the more carbon it's holding inside of itself. One thing you can do, you can just go over here and play around with this. One nice thing about the tree carbon calculator is that it gives you, it's like instantaneous. So there's no modeling or calculations. It's just pulling numbers out of the black box that runs behind it. But you can just play around, like put the different species in here, just call them 40 years to get a general sense, because all the greenhouse gas benefits happen later in the tree's life. Once it's already quite large, it starts to add more carbon to itself at a much, much faster rate. So put 40 years in here. and then change the species and watch this number change and get a sense of how those things differ. But generally speaking, the thing that's most important is how big the tree is.
Okay, great. So next question is, have you evaluated the CalEE mod software as a tool for calculating emissions associated with planting/maintenance? That's from Scott Eckerd.
I haven't. In fact, I haven't even heard about it. So that is great. I'm going to make a note for myself, and then wherever we end up making, hopefully we can make ourselves a list of resources. We could add that to the list. And it was called the CalEE?
Yes, MOD.
MOD.
Software.
Okay.
All right. Next, Catherine Martineau says, it seems important to note that these calculations will most likely not make the difference among applications. She says, I had asked for a definition of significant reductions, but they don't have an answer. And I'm assuming that's in relation to CAL FIRE. We have a question from Kathy Blair. I'm sorry if I'm butchering last names here. Any clarity yet on Cal EPA and Virus Green rating criteria or eligibility criteria? I think this is a question that's going to be answered more thoroughly in CAL FIRE's webinar on Thursday.
Yeah, unless John or somebody is out there and has an answer and wants to just type it into the chat. The
other option here, I know Chuck Mills, our grants manager, is on the computer from home. Chuck, I'm going to unmute you for a minute. Maybe if you have a microphone on your computer, you can give us an answer.
You're on the spot, Chuck.
Oh, it looks like he probably doesn't have a mic on his computer. Okay, well, we'll have Chuck give you an update on that, and we'll put it in the follow-up email.
Okay, because I know that's really urgent, but definitely I do not have the ear of Cal EPA. I got nothing there.
Drew also gave us a link to a paper on native shrubs and carbon sequestration. We'll link to that in the follow-up email as well.
Okay.
And then...
And I'd say in that case, if it's focused on native shrubs, the chances of that being the kinds of things we would want to plant in urban areas maybe isn't so high, but I would think that it would be totally reasonable to do the same kind of species matching. Look for one that's a similar kind of growth form and to what you want to plant, and use that to get your numbers. So,
Eric Aller says, how can planting a street median that is currently concrete capped avoid CO2? I understand the CO2 storage of the trees, but I'm struggling to see how this will create any avoidance.
It probably won't unless that median is within 60 feet of a building. So, but let's not disparage the contribution in terms of carbon stored, carbon sequestered and stored. I mean, that's a huge, especially if it's in a median, you have probably the chance to plant some decent-sized trees. And in the hottest parts of California, in the end, I would say as a general rule, the benefits over a 40-year period end up being kind of not too far from equal, meaning that the amount that's stored by the tree and the amount that it avoids in terms of emissions is they tend to not be wildly different. In a place like, say, San Francisco, where our energy reductions are going to be a lot smaller, that carbon storage benefit is going to be much higher in comparison to the energy emissions reductions benefits. But both are quite important. So I hope that answers the question.
Okay. And then I have had just a couple of bits of guidance come in from both John Melvin at CAL FIRE and Chuck, our grants manager and public policy manager here at Cal ReLeaf. So John says they're still waiting on Cal EPA guidance. This is as far as qualifications.
For the disadvantaged communities.
Right, exactly.
Yeah.
Thank you. He says it should come very soon. If it does not, they may choose to extend their concept proposal deadline.
Okay.
And then Chuck also says that Cal EPA told one of our network members 1 to 2 weeks before an answer, and that was last Monday. So hopefully it will be this week or next week that we'll hear something. That back to questions now. Chuck also has a comment on applicants looking to calculate vegetation management reductions. And those, he says that you should be able to go to Caltrans for a tool for that. Ava, I'm not even going to try to pronounce your last name because I know I will butcher it. The Woods in the Neighborhood and Green Innovations proposals ask for an estimate of greenhouse gas sequestered. She just wants confirmation again that this means carbon stored over the life of the tree, as we showed in the example, and that is the case. It's the total 40 years.
Yes, that's right. And so let me just, while I have this slide open, I want to make sure that people are people get this. It's actually probably going to be beneficial to you to just copy and paste the whole row. So that includes the cooling, the heating, the emission reductions, the CO2 sequestered in that year, the total CO2 stored up to that point. Because once you've got those in your spreadsheet, then you don't have to start, you don't ever want to have to start all over again from scratch here. Just capture all these numbers in a template like the one that I made in the example. And then if you find that you misheard what, you misunderstood what the grant asked for, or if in the second phase of the proposal you're asked to more explicitly show your work, you don't have to start over again. So just remember that this number is going to be for each year, and this number is going to be essentially the sum of all of these numbers that have come before. So this is the one we're asking for now, but it's very valuable to just grab them all so you have them if you need them in the future.
Great. And then I've apparently messed up my abbreviations here, looking at some of the same letters. Chuck's comment about VMT was for vehicle miles traveled, not vegetation management.
That makes more sense, I guess.
We're looking at the same letters all the time, right? Okay, and then one last question. This one is from Chuck. Is there a tool or recommendation for measuring soil sequestration that could help with calculating reductions in community gardens and urban agriculture?
I don't know. I don't know how. Normally, what you're talking about when you talk about the carbon captured in soil is really relevant in an agricultural context, because when you till the soil every year, you spit out a lot of CO2 back into the atmosphere. And so different agricultural techniques can reduce the amount of CO2 that's given off by the soil. I'm not sure that it makes sense to think about that in terms of urban agriculture, but my guess is you can actually just find a number, and you don't really need anything so complicated as a tool. You just need a number that says, in this part of the country, how much CO2 is stored in soil used for agricultural purposes, or something like that.
Great.
And then you would just calculate the cubic feet of soil that you have, and multiply by that, whatever that number is.
And Brent Bucknam has jumped in here and said that there is soil carbon research from Marin Carbon Project, so that might be a good place to look.
Yeah, that sounds urban.
And unless there are any more questions, I've reached the end of my list.
And then I did have this last slide where we have the information for the webinar that's on Thursday. So if you didn't already get that email, what you need to know is right here, and it will be attached to the PDF that will go out with this presentation on it.
And I believe Nancy wanted to step in here.
Sure, hi. It is also on the CAL FIRE Urban Community Forestry website, so the link is there to find this information. Kelaine, thank you. This was a great contribution, which I really appreciate, and I imagine everybody else on the phone did as well. You really sorted things out in a way that made it a lot more clear for those of us who are challenged in this arena. So I do want to say to the attendees that if you have any more questions, you can certainly get them to us, or most likely get them answered again on Thursday for the CAL FIRE webinar. So thank you everyone for attending. We hope this webinar was helpful in your work and toward funding opportunities. Both California ReLeaf and California Urban Forest Council will be posting the recorded presentation on our websites, and we will email a PDF to all attendees as well. Good luck with your projects.
Thanks, everybody.
Thank you.
Thank you. Bye-bye.
Bye. I'm still here. Are you guys here?
I'm here, but I don't know if everybody can hear us. Oh, John Melvin's calling me. I got to go.
Okay.
Okay, bye. Hey, John. Hello?